So what I did was I took the script that he created, right? I ran the script. I saw the difference. I mean, he pointed out he was expecting some output, uh, uh, and he gave various not him, sorry, he was not expecting output. Basically, he compared the output of ONNX Runtime with that of PyTorch and NumPy and whatever, and for ONNX Runtime also across various settings, right? That is what the issue had. But in all the cases, it is like his thing was like this is the static, this is a constant input, that X is constant, right? That is the one which is being folded, right? That because all the values are constant, it is summing up, and it is keeping that sum in the result. But what I see is that if I make that X variable as a dynamic thing, as an input, I ask Opera to generate this, take exactly the same input, but in the model, make it as input rather than constant, right? I'm getting exactly the same error. Share my screen.
That is expected, no?
No, it should not, right? Then it is not constant related to constant folding, right? If it is input, it cannot be constant folded.
Right? Okay. If you're talking about that same bug, this is the bug around long additions in float, causing some error, right? Causing a measurable error.
Correct.
Okay, if I understood correctly, fine, it was filed in respect to constant folding, but this is a generic issue in terms of float additions itself, right?
That if correct. But you're right that it is around the float addition in the sense of that ultimately, because if we are adding too many floats, we need to do it in a particular fashion. That Kahan algorithm or whatever is there.
If one number is very high and one number is very small, then your additions are going to be lost. Is
right.
What seems to be happening.
Yeah. So now right now my point is I thought it has something to do with, I mean, there is some unique flow in the constant folding that is causing this issue, right? But if it is something generic, not necessarily tied to only constant folding, then I'm surprised. Why is this coming now? It should be a very common, adding numbers should be very common for ONNX Runtime, right? Or am I misunderstanding?
But this is a very specific type of addition where you're adding, there is one accumulator which becomes very big, and then you're adding small numbers. Maybe mostly it is coming in folding only. Because that if you're adding two big numbers, this issue will not happen, right? This is happening one big and one small.
Right. I guess something of that sort. Yes. There is some unique thing about
it. I mean, whatever time I spent on that day was just to get up to speed to what you already knew, because I completely forgot how floats are stored. So actually, I spent that time only on last weekend to understand the representation of doubles.
Oh, nice! You went over that IEEE 748 whatever 756.
Not exact that specification. Obviously, I used Claude to help me understand by taking example. Basically, first that whole Mantissa bits, that whole representation around how is 32-bit float structured, how is 64-bit float double structured, what is the sign bit, exponent bit, Mantissa. And then once I understood that, then I understood why the issue is happening. And for a 32-bit float, what is the resolution of one single number? So 100, if you have 100 million representation, then the next whole number that it can represent is having 100 million plus 8. If you're adding 1 or 0.1 to it, that completely be lost. Once you understand that whole layout, then you'll understand why that happens.
Oh.
I did not have that whole, I mean, I had forgotten that background. So I tried to understand that part. So that was, I think, fun.
Oh, nice. They say AI is causing the death of computer science. It is actually improving our computers.
This particular use case is really good, right? Like making you, teaching you something. Because this specific thing, I don't think I would have found some very easy explainer somewhere. I mean, I'm sure there are blogs, but I wanted to ask the exact doubt that I had, and it was really good at giving me examples and showing step by step converting a decimal into a decimal float into this representation, binary representation, and then finally showing me why is this an issue.
Right.
And then, yeah, obviously, it explained what this Kahan's algorithm is. And then after I understood, then I asked it to give me a probable fix. I think the fix itself is easy enough, but I think the main part that I did not fully understand is what is the best fix here in terms of perf? Because functionally you can fix it easily, but I think there is some perf repercussions also here.
Right, but okay. What is in your investigation? Where is the issue coming from?
So I can show the code.
Yeah, please. Reduction underscore OPS dot CC.
Yeah, reduction underscore OPS dot H. I'll show my code.
Okay.
Oh, this is my changed code. So let me show the def. There was a particular if else, and there was an agol function, somewhere.
Yeah, algo LL, agro LL or AGGA
Yeah, we had this over here. So this branch is the one causing the issue, if I understood correctly, right or no? So what we can see here is if it is an integer, it is anyway working fine because it is, I think it is casting integers as floats. So it is increasing the range of integers by casting it as float. The problem is when it's actually already a float, then it is not actually using Kahans, and it is not even casting them as double. So that's when the issue happens. Is this correct? Like, do you agree till this point?
Right. I'm not sure. As in, yeah, I believe yes.
This is what I remember from my investigation that day. That like float is an issue, but integer was not an issue, and this was because it was not using Kahans and it was not casting floats to double. So I mean, there could have been two ways. One is casting float is always using double, or you can use Kahans for float also. So there, I think what again, this is after this, my investigation is not there. I mean, I had to stop after that. But what at least the AI told me is there are perf kind of repercussions in both. In Kahans, it is kind of iterative, is what I understood. I might be wrong. So it can potentially slow it down. It can potentially be an overkill for certain situations. So it recommended me to just cast them as double. Floats as doubles is what. So that is why it added double accumulator for floats. You see the static cast as double, and then using the double accumulator, which is what it is doing for integers, I think already. Yeah, for integers, it is doing the same thing. It was not doing it for floats. So, and it was very, very confident that this is the right size. But yeah, after this, I did not invest too much time.
Right. So there is a PR attached to that issue, right? Your change is in line with that?
Not fully. I think that PR is a good point.
Yeah, that PR is slightly strange there, right?
Yeah, because I mean, it was assigned to this cloud copilot, which I believe is not as comprehensive as your local coding agents, I think. It was a very small PR compared to what I have. But do we want to inspect this PR, that PR?
Yeah, let us check
that.
Can I share the link?
Yeah. I don't have the link right now handy.
1 minute, I'm sure. I'm sharing in the chat. Can you open?
Yeah, just a minute. Okay, so files changed. So this is using Kahan's. That is what it is doing.
But the change it is doing is from that guy, no? It is removing eigen.map whatever thing.
Ah, okay.
That one I'm very surprised there, right? I mean, will eigen is it because we are using float this is causing the problem? Because this should be, I mean, it should work, right? Like I don't know. I'm
This one?
guessing that.
You're talking about this one. Okay, this should have worked, is what you're saying.
Yeah, that some of on the from that eigen library.
Because it is float.
Only because it is float, it is failing. Is what you're saying.
Yeah,
But
that is what my understanding is.
Okay. I mean, I want to be sure the sum is from eigen only, right? There.
Correct.
Right. So what we are saying is eigen has eigen library. Eigen, I believe this is eigen library. I'm just going by the namespace, which is a very highly regarded library. So
okay.
they exposed a generic function, generic whatever templated type with some implementation, but that some and so they are essentially saying we should not be using it for float because they should be handling this, right?
Got it. Yeah, I was not aware about the eigen library, so yeah, that does sound a bit surprising. If it is very highly used library, then this should be a very common, well-known issue that they would have rather fixed. So yeah.
Yeah, let me ask this guy.
Okay.
Copilot, if
you want to share your screen while you are asking it?
just one minute. I'm just putting whatever I asked you on the. It is Kahan algorithm. Oh, okay.
So I can assume that users who need higher precision will use higher precision type called double instead of float. So maybe they knowingly didn't implement this fix or optimization, so as to say.
Yeah. But the difference is too huge here, right? For these. In its reduction sum kernel rather than delegating to eigensum. Oh, okay. I think you implemented Kahan, right? In your fix.
I thought I'll implement Kahan, but AI was very overwhelmingly pushing me to use double. So that's what it did.
Oh, okay. But but the PR is actually showing this on
PR is showing Kahan, correct. PR is using
right.
Kahan.
They explicitly gave the link of
yeah.
But here it says that the issue it is about whether ORT should use a more accurate.
Yeah.
Basically, here what it says for integer types to prevent overflow, it is already using Kahan.
Yes. That we saw.
Yeah.
It could potentially do the same for fruits to improve accuracy. Yes.
Right.
Should we ask it now that what if we just cast floats as double and not use Kahans? Would that work? And how would you compare those fixes, those approaches?
Acha.
Yeah, this is a fix that my AI did.
Oh, okay. So the issue here is only whether what happens if it is double vector. But
Yeah.
what
The approach doesn't help for
actually-
double inputs. Yeah, that is expected.
Oh,
Apparently,
okay.
Kahan is the slowest implement. Okay, slowest in terms of speed.
Hmm. Good. Oh, yeah. And we will be able to use the SIMD vectorization, is it? Oh, that is interesting. So shall we see if ask it to make that change and see if your change and my change matches?
Oh, yeah,
Or
sure.
the AI? It
Yeah,
should be, right? It should match.
it should be. Yeah, the change in itself is very simple. I think it should match ideally. Just that in my case, it actually modified more functions because I thought that other functions also had a similar issue. So
Oh,
that's why my change looks slightly better.
okay. Let me see if, what it will do here. Oh, these are the other functions you are talking about.
I think so. Yeah.
But it says they are using Kahan for integers, right?
Yeah. You were saying
So
that why are they using it if the speed is so slow? They could have actually. Okay, wait, no. They are using Kahan somewhere. That is correct. But they're also casting integers as floats. So if they're already casting integers as floats, why would they need Kahans? Let me recheck the code again. So what I see is there is a if-else condition. If there's a constant expression, use Kahan. If that is true, they use Kahans. Otherwise, they're casting integer as doubles.
oh,
Line number 241. Check it out.
line number 241.
Yeah.
For provider CPU reduction.
If the type is int64 or unsigned int64, it will use Kahan. Otherwise, it will cast it as a double for the integral type. So I don't understand this part. Why?
What is this I'm saying? For providers.
It's for int64s they're using it, right?
Yeah, int64 and unsigned int64, they're using Kahans. But for other integral types, they are casting it to double.
What is the line you said? Sorry. 246.
241, the line number. In your case, it is 246 because I had a local change.
Yeah. Oh, this const expression.
Yeah, this const. And this const expression is around the type being integer 64 or unsigned integer 64. So if that is true, it will use Kahan. Otherwise, it will use static cast to double.
I see. Oh, is integral is okay. I think we should just change this to include float as well, right? So that it will go there.
There is a there's 169 you're saying. Reduce, use double.
Yeah, basically,
okay.
yeah, double accumulator. Isn't that not what it is?
It already has float. Now go back to the code. It's same as T float, right? So it's already there, no?
Yeah.
The OR condition is there.
Wait, what is saying? Types that benefit from accumulating a double up includes all integer types to avoid overflow and float to avoid precision loss. Oh, I got the fix somehow. Then I'm not getting your. This is the same fix bug, right? 285450. This is what we are working.
Did someone fix it?
No.
And you are on the latest main?
Maybe
no?
unless this guy fixed it. Oh, let me see. Oh, it changed.
It changed, no?
I think that is the only change in integration. Yeah, it added that.
Okay.
Okay. We were too a few seconds delayed. That's it. Acha, earlier it was is integral. Now we are it changed this guy. Copper changed it to this is integral and
makes sense. It's slightly cleaner, no, that way.
Yeah. But still, I have one question though. This one is in. I don't know what other providers are there other than GPU.
There is CUDA. There were more actually.
Yeah, this good question part should be removed, man. This is nonsense. EP.
There is web. There is web GPU, CUDA, CPU.
Oh, right.
And there is a training provider. So this might be that specific training use case for ONNX.
Oh. While it searches, shall we quickly see this code, the library, the issue he gave, the Python code that he gave. So where did torch.once this, and he's using float 32 only, right? Torch.once that make input. This is the script that he gave.
Okay.
Right. And this is how he's creating that input. This is torch.once. I'm guessing these are all the dimensions of that.
Yeah.
Right. And that float 32. So where is that part? Where you mentioned that there is one very high and there is one very low. Those things
So
that are
when
there.
it accumulates, so eventually
Oh.
that accumulator will become very high. No, that is the part I'm saying.
Oh, because these are this many.
The numbers are so many. So eventually there is accumulator, so it will grow big, and then after
Oh,
that
okay, okay,
the
okay.
error will start coming when you keep adding this point one to it.
Oh, looks like we have problems in other things. Oh, now what do we say? Is this a fix or consistency matters or this?
Oh, CUDA has the same issue.
Yeah, and in fact, it cannot be fixed like this.
Yeah. Oh. CUDA use accumulation type float, no promotion to double. The custom kernel does plain value and also accumulates in float. So large float reductions on GPU should have the same precision loss. Then someone should have reported, no? This is strange.
Hmm.
Can we ask it to repro it using CUDA?
What we have CUDA here on Mac.
Oh, we don't have CUDA here. Yeah.
This is CUDA. I don't know. We will have, right? I don't know.
No, where will we have?
I'm publicly acknowledging my ignorance here. It is some just a library for GPU, right? I don't know. Mac does not have GPU from NVIDIA.
No.
No.
Okay. So for consistent, if we move to that Kahan, we will get that pairwise summation. We might get consistent behavior across the.
Yeah. The pairwise summation, if I understood correctly, you will just start pairing numbers so that one number doesn't grow too big compared to others, right?
I mean, you add only to. Yeah, I think
Yeah.
it pairs and you keep.
Yeah.
Then you
So,
add
so
two
numbers
pairs
remain
and add
comparable.
those as a
Yeah.
tree types.
Correct. So that also it said it is good only, no? In terms of parallelization and all.
Right? Is it? Okay, let me see. This one. Yeah. Pairwise summation, good. O log n error.
Okay.
Fast.
There is still some error over there.
Oh, there is ends indifferently as well. Acha, the error is smaller. Is what. Shall we ask it to do?
Yeah.
There are.
I got that other issue that why is it forking the implementation for interiors?
Sorry,
You
what?
got no, there was this if else condition for integers. No, so I was trying to check that on the side. Why is it forking that implementation? Why is it using Kahans for certain? So it is because int64 is already too big, right? So
Right.
the 53-bit Mantis for double is not good enough for 64-bit integer. So that's why it is using Kahans for that because it cannot use any other type for int64, and for smaller integers, double is fine. So that's why it's using double. So yeah, that makes sense now.
Acha, exact cross EP numerical consistency for so acha, this is not even a practical goal, it seems. Interesting.
For GPUs, existing hierarchical reductions are already reasonable. Exact cross EP numerical consistency for fluid reductions isn't the practical goal. The ONNX spec doesn't guarantee it either. Oh, okay. Oh, so CUDA apparently does already pairwise. So maybe it initially what it said, probably it was never as bad as CPU.
Right. There is some error, but not as bad as CPU.
Yeah.
Okay. Then what next? What we should do?
Do you want to submit a PR?
Okay, I'll ask you to. Can you please build it? I think it has already built it. Oh wait. Hold on. Oh, okay, cool. So, what the Python things are Python?
It should run the test, right?
Yeah, I created one. Then I will just quickly run that. Yes. Oh, I'm already on this.
You can just do slash. Okay.
Yeah, I'll share this. Let us compare against the output. All right.
What are you typing?
He's trying to paste, I think.
Oh.
You have to undo that line.
Yeah, you typed some garbage at line 22.
Yeah, I'll do. This is our output. I'll get his. I'll get his change. I'm starting at the same number. Yeah, same line. Yeah, difference is now much limited. Okay, seems like the fix. What 248? What was the number?
28587.
Issue is 28450.
That is the PR number.
Oh, sorry, that's the PR number. Sorry.
Yeah, Yeah, 28450.
I hate math with the passion. Huh? Okay. What do we are we publishing? What do you want?
Yeah, why not?
I don't know. Seems slightly shady. Yeah, I think we did our homework. Let us.
Okay.
Yeah, give me a commit number, commit message. We'll ask Copilot only.
Yeah.
Do these guys have any rules for Copilot these things?
Yeah, exactly. I think we should just give it and add it as a comment there. But this is one thing we did it using Copilot, whatever. And
Yeah.
Let's see. I'm checking the contribution guidelines on the side.
further by Copilot. Yes, please. Git commit -7.
There is nothing around AI in any of the contribution guidelines.
Plus 285. Yeah. Nice. Log improve this. Only our change. Okay. Push तो कर दिया मैंने, but I'm not sure whether we want to raise here or not, or just leave a comment here. What do you guys suggest?
But
Are
what,
there any ethical things here?
because we use Copilot?
Yeah. As in yeah. I mean, we are being public about it, and it is Microsoft, so we should be fine.
And that is okay, right? Because even the current PR is authored by Copilot.
Yeah. So they assign Copilot to this, and
Yeah.
Copilot link. I mean, okay. What are the three options that we have? One option is we can show our fix. We can get a commit. Yeah, I don't know. Do you want to raise or not?
I don't see any concerns. Alan, do you see any issue?
No. Out here, it doesn't look like they are reviewing everything or accepting everything anyways. They go via Copilot. Plus their number of PRs also right now 567. So it's not that they are getting bombarded by random people doing, just using AI and pushing code. And there's no guideline or anything, but I think in the description at the bottom we should go ahead and just mention it.
I think it's already there, no?
Already there, authored by.
Then we are good.
See, if I'm sending, I will CC you and Priyank there to show the true authorship or the.
That doesn't matter, but I think we should raise it. Yeah.
Will raise.
Yeah.
Okay, I think we should still mention this guy, right?
What?
This PR you are saying.
This PR.
Okay, the original.
28587. Oh, we should run some tests, where
we have to add some tests.
That we have to do.
Shall we do? Hey, yeah, I mean, I'm slightly that we might be missing something, right? No.
That's fine. Don't raise it now. Then it's okay. We can raise it later if you feel that. But just to go and complete it out, maybe those tests that run the existing test again and see which test. Ask Copilot to add tests for this.
But is it describing in our PR? Did we add this?
Is this linked to the bug? It's already there, right? You added that.
Yeah.
Fixes.
We can easily hash. This will fix.
Yeah.
I think first anyway we need to fix this guy, right? As in this description, we need to add a little more saying why we did not use the or the limitations that it won't fit for double and whatnot.
Okay.
And also our that we looked into the other things that web GPU and all have already pairwise summation.
Okay.
I think whoever assigned it to Copilot, they are just they don't have time. I guess they just ask Copilot to.
Yeah.
Yeah. Cool. Nice. Not bad, right?
Yeah. We understood something. We were able to add a potential fix.
I think Priyank can do a segue into his investigation on floating point numbers.
Yeah, please.
I should have preserved this thing.
Ask now, no, again.
It should have a session stored.
It would have been very old, but we can do it again, no?
Yeah.
Should we do it again right now?
Yes.
Okay. But how many of both of you already know the issue, why it happens?
I don't know it completely. I know only very basic. So.
Okay.
Yeah. After you explained on that, I got it. Till then, I thought it was something to do with. I thought it is much more generic behavior here.
Okay. What do you mean by much more generic behavior?
As in, I was not sure that is the fix, because I thought this should be. This is it is not tied only to.
Got it. That big number, small number, you are saying that made the difference for you. Okay.
So I will try and repeat my understanding. Tell me I got it or not. So the what the user is saying is he created a huge matrix, and with all of them some into 0.1 or something like that. So all the numbers are between 0 and 1 essentially, and then he sum. So after a while, because it is the accumulated sum is huge, and that is getting added to very small number. That is the cause of this issue, correct?
Yes. And that's what we'll try to see why that is the case. This is the bug, right? 28450.
Yes.
I'll start with this, and then we'll keep going deeper. And this part we already know that is specifically in the float 32 part. So in his case, the total number was 1 million. 1 million numbers in that matrix. All 0.1.
That 5 into 68 into 64 into 64 is that big number, is it?
Yeah. Okay, it started with something here, right? So for this repro, 1.3 million values of float 32, expected real sum is 139,264. Yeah, of course, because all numbers are 0.1.
It should be a little less than that number.
Around this number, adjacent float 32 values are spaced by this. So each 0.1 cannot be represented exactly against the growing accumulator. It gets rounded to float 32 grade again. This is the part we want to understand fully, right?
Correct.
So this is where the interesting part starts, right? So this is something I had completely forgotten earlier. How the floats are stored. So float 32, the only part I knew is that, okay, it uses 32 bits. But then how are those bits structured? So the first one is your sign bit. Then you have your exponent bits of this thing. 8 bits of exponent, and remaining 23 are fractions. So the actual accuracy is coming from this remaining 23 bits. So that's what you have. And similarly for double, it's almost exactly the same. For double, this number is around 53. I think 53 or 57. And what this exactly means is, let's say we have this 139264, right? How will it be structured? Every float is converted into this representation. And this number here becomes the exponent, 17. Sign is self-explanatory. And this, after this point, whatever is there, right? That is what this one point is. So this one is constant. We don't need to represent that. But whatever comes after this is what these 23 bits for you represent. Is this part clear?
Yep.
Yeah. So imagine a floating point number where so not every floating point number can be exactly represented, right? You will lose some precision because, like for example, 0.3, 1/3 we cannot represent in this decimal representation perfectly, right? It is 0.333333 whatever. At some point you have to stop. Similarly, for floating points also, it would happen the same way. So after 23 bits, you have to stop, and you're losing some precision. You get that part?
Yeah.
Okay. We add the arbiter with align exponents. That means rewriting 0.1. Okay. Should I actually ask it to convert this into this representation one by one?
Oh, it can. Yes.
I mean, it can show. It can try to show you.
Yeah. Let us see.
Okay.
Maybe it will write a Python script or something.
Maybe it'll write a Python script. I want to understand how a decimal would, how a float would be converted to it. Show this transformation step by step using an example.
By the way, ChatGPT does a good job of explaining this.
Yeah,
It's
because it's
like more
it's got
visual
CLI,
than
right?
command
It's more
line. Yeah.
visual. I actually use that. Do you want to show what you have if it is better than this?
I can show it. So let me share my screen. So there's one very old paper on, I think on the Oracle website, which it's on the Sun website, Oracle website, it seems to have gone, which talks about what every engineer should know about floating point arithmetic. It was a huge paper. Like I have the printout with me, but I'd forgotten everything when you were saying some things were coming to mind. But I'm not getting that paper. So I asked a basic question right now. That I gave it the issue first and asked details, explain what is the issue. So it was able to explain. The next thing I said that, okay, just help me understand why this issue occurs with examples and with the explanation using floating point arithmetic, right? So here it started with basic floating point arithmetic. What exactly happens, right? So some of the things that you were also mentioning. So where is the accumulation error occurring? So a random example of 10 into 0.1, right? In reality versus on a computer, there might be an error that's introduced. And then this also, that the order, the sequence of your operations also kind of either can increase or decrease. That's where I think that pairwise summation optimization is. Yeah. So the other thing was interesting was, this is still order and why reductions are tricky, right? So the rounding error is basically your error is being accumulated on every step. So there are different strategies to go ahead and do it. And this one, I didn't know what is PyTorch got 139.264.05. The exact mathematical answer, PyTorch float 32. This is the error. Okay, now I think it's coming back to the original issue and mapping that. What is the issue? ONNX Runtime provided this. And the relative error is 0.17%. Okay, this one, I don't know what is this trying to talk about. CPU reductions with sim and dash. Okay, yeah. So why float 64 works? 52 bits of Mantis instead of 23 bits. If it would have dumped in that visualization of the 32-bit breakup in here, it would have been great.
Maybe it would do it if you ask.
Yeah. Should we ask it?
Yeah.
Absolutely. Visual यही है अपना markdown based visual. So it's not doing the visual. Okay. Okay, what do we do next?
Hey, what was it saying about SIMD? Just can you scroll back a little?
What SIMD bug might look like, or SIMD reduction, what ORT likely uses.
Okay.
What a SIMD bug would look like.
So this guy now actually gave like one by one step of how it converted to get to the exact number that ChatGPT also gave. Like what is 0.1? Yeah.
This is an interesting use case.
This is
right?
nice.
Yeah, so you have to, this is the main part, right? This 23 fraction bits is the main part. This is like pretty simple, exponent and sign bit. So how do you get those fraction bits? What is the way to convert it? So you keep multiplying this by 2. And if I am kind of understanding this correctly, you keep doing that till you get a remainder of 0, I think. Then if you, at any point, if you get a remainder of 0, that means that you get an exact representation. Otherwise, you keep doing it till you run out of your bits that you have. So we start with 0.1 and you multiply it by 2, you have 0.2 and bit 0. So your bit is 0. Then you again multiply 0.2 by 2, 0.4. Again, this integer bit is 0. You keep doing that. I think this will not end because 0.1 does not have an exact representation in FP32. So your Mantissa bit becomes like this 0001100 and it keeps going on. So that is what you will see, I think, here. Where is it? Sorry. 0001110, and it'll keep going on. And because you always need this 1 here, so the exponent will become minus, I think. So this part is clear, right? Why 0.1 does not have an exact representation and why you will lose precision after 23 bits. So that's why it is not exactly 0.1. When you convert that FP32 representation of 0.1, you will get some 1 point something. 0.1 something, not exactly 0.1. This is the part I'm slightly confused about. So yeah, till here I'm fine. Now it says the bigger issue, sorry, as the running sum grows, FP32 spacing grows too. And near 139.264, the float values are spaced by 0.015625. Is this part something you understood?
No. The part where, yeah, the bigger the issue is with the accumulator, that part makes sense. But this explanation of this particular number and what is the spacing he's talking about, that size can be
Adding 0.1 to a value of the exact number cannot be represented. It must be round. It must round to this grid. Okay, here I'm confused again.
$9,264.
Where is 9,264?
No, that number that it specified, is that specific to this issue or is it in general there he's trying to say?
Oh, yeah, this is just an example because this is the number in the issue. So it's a general issue, nothing around this number. It's just taking this example. But again, I'll ask, even sir, you got anything or should I ask this guy only?
Ask it, but I thought it is, you explained earlier, right? As in the, at different numbers, the range will change, right?
But now I'm forgetting that understanding that I had. Why would it change exactly?
So it is, we had said that there are 17-bit representation, right, for the exponent. What is the Mantissa and exponent?
Mantissa is 23.
Okay. Let's see what it says. Then there's the ChatGPT gave one answer.
What is the ULP size? Yeah, fine. Okay. I was fine till here. Fine. The smallest change can be the last bit, which is this. But this is always the case, right? But because the whole significant is
even
scaled
below
by
that,
2 raised to 17, the absolute value of the step is 2 raised to 17 into 2 raised to minus 23. Okay, this is the part that I need to understand that.
the calculation at least makes sense, right? But why is it that, is it at 2 raised to 16, the value would be like less than a smaller number, like a very small number? What is, let's see.
Yeah, the resolution increases at lower numbers is what it is trying to say.
What do you mean the resolution increases? The error will increase as the
number becomes bigger. So if the number is smaller, you can represent. Okay, what
but
is the?
Why is it that? Yeah.
That's what I'm also trying to understand. Hemant sir, you want to explain or you want us to keep asking AI this part specifically? Did we lose him?
He got fed up with my dumb questions.
Hey, hello.
Hey.
Yeah.
Hey, sorry, my headphones are acting up. Yeah, so so there are only 23 bits for that guy, right? For the decimal portion, correct?
Yeah, correct.
Sorry, no, for the what?
For this portion.
Yeah, right. So out of the float 32, out of the 32 bits, one for this, one for sign, one for 24 for this guy, for the point before that, for the number before this, right? And remaining is what? 8. How many?
8 exponents.
Right. So if our number is at that, I mean, so if we are talking about something between 2 power 17 and 2 power 18, right?
Yeah.
Now what can we? So we have uh, that is fixed, right? These are the 17 bits. These are the 24 bits these are the 17 bits that are needed. I mean, these are the 24. Out of these 24, these are the 17 that will be used for representing any number between 2 power 17 to 2 power 18, right? So now, if you see that one, the range of numbers, whatever is the all the numbers from say 2 power 17 to 2 power 18, all the real numbers between 2 power 17 and 2 power 18 will have to be filled with only those 17 bits plus 23 bits plus 1, the sign. So ignoring the sign for a minute, those 17 bits plus 23, correct? All the real numbers. All the real numbers, because I mean, what is the alternative there? See, I mean, because it is 2%, I do not know what is the value of 2%. Let me take that exactly. See, let us take 139,264, right? Whatever. 139,264 will need 17 bits, I guess, 17 or 18 bits, whatever. But so 139,264 say 139,265, between 139,264 and 139,265, there are a lot of numbers, correct? A lot of real numbers, right? Now, and it is not just those. I mean, because 139, not just 139,265, because it is 17 bits that we have. We are looking at. We can go from 2 power 17 to 2 power 18 as far as the this number is concerned. The number before the decimal is concerned. The integral part is concerned, and the decimal portion is so. You will only be able to, of all the possible numbers of between those, you will only be able to spread them in that with those 23 bits only, right? So the delta will be, so you will have to increment it, like, I mean, you will have to increment it with that 2 power 17 into point that to get to the next number. I mean, let us take what is 2 power 17. Let me just check 1 minute. Just give me 1 minute.
2 power 70. 131072, it shows.
Yeah, 131072, right? Now, what is 1310? Imagine 131072 in this in binary format. You will have 1 followed by 16 zeros. I'm using. Let us ignore 2-bit 2 complement portion. 1 followed by 17 zeros. Correct?
17 zeros. What
16
is
zeros. 16. In binary format, 2 power 17 is what?
Achha, that way you're saying. Sorry. Fine. Yeah.
Correct. Right, one and 17 zeros, correct?
Yeah.
Now, and imagine it is the real number. So all the 23 bits are 0000 only, correct?
Yeah. Okay.
Yeah. Now, now let us add small. Let us assume we will not define it yet. Let us say there is some delta that we can add to it, right? Some delta, which will give us the next possible number after it, right?
Okay.
So 130.131072 plus delta is what we are talking about. I mean, point something, some number, some delta.
That delta
right?
should always be this, right? 2 raised to minus 23, no?
No, hold on one second, right? Now, let us keep that delta there. I believe they are not treating it like that, right? The reason is like this. So you start with 2131072, which is 2 power 17, and you go to and you 2 power 80 is 262144, right? You go from this 17 to this. You keep adding these small deltas, right? Now, ideally, you should, if you add sufficient number of small deltas, you should reach 26, whatever, the next one, 262.144, correct?
Correct. At some point, I will reach there.
You will have to reach there, right? Now, how will you be able to go about it? You will modify those bits there. I mean,
the Mantis bits there.
Some number of deltas after you add some number of deltas, you will go to the next integral number 261. 131073. After that, some number of this delta and so on, right? Now, if you see now 2 power 17 to 2 power 18, and these are only 23 bits. So that is what they are saying: 2 power 18 minus 2 power 17 into 2 power minus 20. 2 power 17 into 2 power minus 23. So essentially, you are going to have that many those deltas. You will be able to add.
Okay. Got it. That is why at smaller exponents with the same number of bits, I will have more number of steps going from one exponent to another exponent. That's why the error would be lesser. Okay, yeah, this makes sense now.
This is not correct. Why is it not showing up? Oh, preview. Okay. We'll describe it.
It'll look at the PR description if it does.
It just figure out.
It should. The request is still in progress.
We'll decide the whole PR. It should be able to go and see this, right? This connect.
It should. You can try it, no? That add that comment. If it does not, you can always add the description again.
This is enough.
We'll try it. If it doesn't do anything, maybe we'll edit it, post something extra.
Oh, maybe we should mention that it is in the. Okay.